Let's see. Yeah, actually, I'm going to talk about Eclipse. But first, yeah, I'm Justin, as he said. I work at JetBrains on the INTELLIJ Scala team. And you can follow me on Twitter as ebenwert. You can post questions if you have them during the talk or ask them later. Later during the unconference, I'm just going to be there for you to rant at me about all your problems with INTELLIJ. But for now, this is fork it harder, make it better. So you saw this background picture. Who recognizes this? Yeah, that's right. It's called the Scala tooling ecosystem. So the purpose of this talk is to give you a bit of an overview of various tools in the Scala ecosystem and outside of the Scala ecosystem. And maybe I'll have a chance of inspiring somebody to work on any of these things or different things to improve the tooling ecosystem and bring it together better. So, because I think there's various tools that have the potential to improve your development experience, all our development experiences, and they might be underused because of issues how they are integrated or not as integrated as they could be into the overall workflow. So I'm sort of structuring this talk as a Hegelian dialectic with a thesis, antithesis, and a synthesis. As you see, it's illustrated by Hieronymus Bosch, and the lyrics are by Daft Punk. So the thesis goes like this. Fork it, make it, do it, makes us harder, better, faster, stronger. What am I saying with this? So I'm using the term forking quite liberally here as making anything new that is sort of related to the old, but a bit different. So that can be a literal source code fork or just a completely new tool. And so this forking might make the whole process of developing harder to learn, but it might enable us better and faster ways of doing things and in the end make the ecosystem stronger. So I'm going to assume some familiarity with common tools, but overall that's not a requirement. So let's just zoom in a moment on a few things we can use tools for, like learning, experimenting, editing code, exploring, understanding, debugging, building, dependency management, publishing, versioning. So since my talk got expanded to 40 minutes, suddenly I can actually go into most of these topics briefly. And the first one will be learning and experimenting. It's, I think, a very important and undervalued part of the whole coding process, because you don't usually start with a complete code, complete way your application works in your head. You have to experiment with the APIs you code against. The actual problem you solved is maybe not completely finished. So there's some tools that can help with that. And I'm on the wrong slide deck. That's unfortunate. Let me just switch. I hope this one is the right one. Oops. So the classical tool for this is the AMMONITE REPL. No, the REPL as such, Scala comes with one, and it's the one that is delivered with Scala is a bit limited. So AMMONITE is an improvement on that, which offers you various features such as history, search, syntax, highlighting, block input, undo, redo, and many more artifact imports and others I don't even know about. Improvement on this, is, or not an improvement, a different way of approaching this is the worksheet, where you have a persistent state instead of going line by line and editing stuff. You have an editor where you enter stuff. Here's SCASD, which is on the Scala website, and it allows you to import SBT artifacts, which I'm doing here. I'm just trying out the GigaHorse HTTP library. I'm gonna copy the example from the website, edit it a bit to download the page. This is a web-based thing that I'm actually working on right at this moment. Just look at me, I'm mind coding. And yeah, you see it downloaded some stuff. Sorry, it loops. And this is practical for quick reevaluation of self-contained pieces of code and sharing working code examples. And my favorite approach to the experimentation is actually notebooks, which combine the iterative updating of your program state of REPLs with a persistent editor like worksheets. So here's JUPYTER. I'm sorry, it's a bit small, but you get the idea. You have cells that stick around. You edit the cells. You put in some code. Here I'm just loading, creating a histogram of pictures, of characters in a string. And one feature many notebooks have is some graphical output, and here, like a printed histogram, for which I just use a library. I play around with it, and it's all dandy. The notebook was actually pioneered by Mathematica some 20, 30, I don't know how many years ago, and I think Mathematica is still one of the best in class in that regard. So Mathematica doesn't just use it for editing code, but also for documentation. Here I'm looking up the nest function. And what I can do is there's some neat graphical examples. I can just instantly change them and see what's happening. Here I change a X for a U in the nest function, and I got inspired to download this picture from the internet. I'm gonna scale it down a bit, and 20 pixels, yeah, that's neat, and put it here instead of the U, and you've got a Sierpinski triangle. You're welcome. So yeah, it invites playing around. I love it. I think it's the gold standard. So I think this would be really great if we had it for Scala. I think we support something close to this in Kotlin nowadays. So there's actually a web page where you can see code examples, change them, and run them. So next thing, editing and understanding. So editing code is not just typing, otherwise we would still be using editors like ed or vi. But often you need to understand the code in front of you as well. So another example from Mathematica. So I think syntax isn't something that should be fixed. The syntax is your interface, so can't you play around with syntax more? So Mathematica is helpful in that it can pretty print, and now what I'm doing here, I'm just pressing one button and it transforms the format of this mathematical formula. And I can also do this as a function. So here's the input form, which is what you use normally, and here's the full form, which is close to the Lisp S expressions. And why not print this as a tree, a syntax tree, right in your notebook editor? Now, down from ivory tower, back to the bare metals. One thing I came across is the interactive disassembler. So if you know assembly code, it's just one long, big list of commands and hard to see the structure in. So why not print it as a graph where you can follow the code structure more clearly. That might not be entirely applicable to Scala, which is a more structured language already. But another approach that went around a while is this Code Bubbles IDE, which is, promised Eclipse. This is based on Eclipse. Unfortunately, not available yet in INTELLIJ. But where you see here, you can actually navigate from one part of the code to the next and have the relevant parts of code next to each other on your screen instead of jumping between windows and maybe arranging split windows and moving things between them. You just have them here neatly arranged next to each other. I think this would be really great if we could develop it further. The state is this IDE can't even import Maven projects, so there's a lack of integration again. But maybe files as primary way of organizing code could be obsolete, or at least go into the background. So compiling, to get from your code to working software, you have to pass the compiler, at least in Scala. So in this sense, a compiler is yet another tool. And here we have an actual fork, type level Scala is a fork of the main Scala Lightbend Scala compiler, which attempts to maintain binary compatibility, but make new features available more quickly. So if you have a cool idea of what would be great to have in Scala, then you might try to get it into type level Scala first and make it available to those that use it before getting merged into mainline. Another approach, Eugene Bormaco talked about it yesterday, day before, I forget. The reasonable Scala compiler. So who watched that talk? Yeah, many of you. So just kind of an experimental re-implementation, but as he told us, he's making progress with that and maybe making it possible to actually compile Scala more quickly. Now, Bloop is not a compiler in itself. It's a compile server developed by Scala Center, which runs on your system and keeps around a hot compiler to actually take advantage of the JIT compilation that the JVM offers. And that can significantly improve actually compile speeds. And it integrates with build tools such as SPT and others. So that was the sort of on the edge to building, which is my next point. So you don't, to get working software, you don't just compile it, you put it together to create releasable artifacts. And that involves many steps, such as dependency management. So let's have a look at build tools. Not everybody, or developers in general, don't seem very happy with their build tools, as evidenced by the fact that there's one for every letter of the alphabet that ends in ake. And these are just the ones ending in ake. In Scala, I don't think we use many aches, but we have aches, like headaches. These guys are feeling it. So in the right corner, we have the old school JVM Java build tools such as Ant, Maven, and Gradle. Does anyone actually use Ant for Scala? No, I didn't think so. Well, actually, we recently as last year, we still had Ant in our code base. In the left corner, there are the more Scala-focused ones, such as SBT, of course, CBT, and more recently MIL. And here in the middle corner, I placed the new school cool tools such as Bazel, Pants, and Buck by Facebook, get it? Facebook? Which are more focused on mono repos, so big code bases. And yeah, what's that? Yuri just snuck in there. John? Did you do this, John? Where's John? He's hiding. So Bazel, developed by Google, originally Blaze, is, yeah, as I said, focused on building tools in a big unified monorepo code base. And it aims to still be able to provide fast and correct builds. And how is this done? By providing, so for each task, each little part of the build, you fully specify the inputs. And that means this part is completely reproducible as long as your code is otherwise deterministic, your build code, and thus outputs may be cached. The SBT contenders, MIL and CBT. So SBT used to, a long time ago, have a pure Scala library configuration. Then they sort of have moved away from that, and people were unhappy, so they started making new tools which are configured in plain Scala. They differ in some more or less minor ways. MIL tries to take a bit inspiration from Bazel by having targets which are by default cached. In CBT, caching is left to the user of the tool. We had 40 minutes.
Really?
He just said I have 2 minutes left. Okay.
Let you come back.
They both use Nailgun for running in a background process, so you have more responsivity than with SBT typically.
Just my mistake.
Okay. So yeah, we've got our build tool. Now we want to actually create a library. And this is notoriously complicated in JVM land. So I looked around, I looked at Cargo, the Rust build tool, and I'm going to see how hard that is to create a library. Here I'm just generating a token, just pasting that into my REPL and creating a new project. And let's open this up, see what Cargo did for us. Okay, just a simple configuration file, a simple code, piece of code. I'm gonna check this into Git, commit, and see if I can publish this. And no, that didn't quite work out. It wants me to fill some fields. Wants me to be explicit about it, so I have to describe what I do here. I fork it harder, make it better. Give it a license. I think the WTFPL is appropriate here. And let's try publishing again. Yeah, I type slow. Publish. Is this working out? Uploading. Looks good. Looks good. Yeah. Okay, I'm gonna check out the crates.io, and there it is right on the first page. Yeah. So that took like maybe 2 minutes of real time, and in that time, and I couldn't even create a ticket on Sonatype. So I also looked at Elm, a language I like a lot. The publishing process is similar, slightly more involved, but not much. It involves pushing to GitHub. But what I liked here is the versioning. So I have this package 4K harder, and in version 2.02, it just contains this one function, harder int to int. I add another function called better, and Elm package offers a tool package diff, and it tells you if something is a minor change or a patch change. So here, the compiler is basically already requiring that I document everything that I want to publish as a public update. So I do a diff, and it shows me this is a minor change because I added a function. And you see, I entered the bump command. It automatically bumped my version up to 2.1. And so I commit this and try a publish, and oh, I need to git tag. Okay, fine, but it gives me everything. It hand feeds me everything I need to do manually. I try a publish, and that seemed to have worked out, and I have a version 2.10 in the package repository. Now I decided, okay, this better function doesn't really make it better. I remove it again, update the docs appropriately, and doing a diff, it tells me it's a major change because the code is incompatible, not backwards compatible. So do the same thing again and publish. Yeah, looks good. Version 3.0, git tag, okay. Success. Yes, version 3.0 is online. Nice. So, yeah, I mentioned dependency management, also known as scavenging code from the internet. In Java, if you use SBT, just downloading dependencies takes forever. So Corsair is a nice tool. I hope we're going to move SBT to Corsair soon. Other tools such as Mill already use it by default. And it just downloads faster, and that's a very reasonable thing to have. Maybe less dependency manager, but package manager. Nix is not a Scala thing as such, but there is a whole Linux distribution based on it. It's kind of similar to Bazel in that the idea is you fully specify the input and the environment in which a package gets built, which allows you to deterministically create exactly the software that you will install and also cache these artifacts. So there's actually a SBT plugin which will allow you to create a Nix build out of a SBT project. Anyway, back to Java. So I mentioned publishing on Sonatype is hard. Maybe you just want to get some code out quickly for someone to consume. You can publish it on GitHub, and the user just adds the JITpack resolver, and JITpack will build it for you. I'm not quite clear on the limitations of this. Like, maybe it might fail for complicated SBT builds, but in general, it will just work, actually. So that was a collection of random tools that I liked. So now to the antithesis. More than ever, hour after, our work is never over. So I'm saying, like, creating ever more tools might, make everything harder because we have to learn more tools, learn new stuff, integrate these tools. So why shouldn't we work on with the tools we have and just improve them incrementally, bit by bit, hour after hour? and put our effort in there. I mean, sure, that's happening. So the Scala compiler is being continuously improved, currently maintained by Lightbend. Scala 3 is, of course, around the corner in a year or two. And yeah, you've probably seen what's coming up, like the collection simplification, some compiler performance increases, and so on. SBT2 has been around since quite a while, 2009, I think. It's also maintained by Lightbend. And myself, I've been working on integrating SBT into the INTELLIJ Scala plugin, making the integration smoother, bit by bit. And yeah, you've also maybe or maybe not seen that what kind of improvements are coming. So for me, the server extensibility is important because it will allow me to integrate it better into INTELLIJ, because right now the way it's done is quite hacky. And of course, I need to mention this little product I'm working on myself. The INTELLIJ Scala plugin has been around for quite a while. From December will be 10 people on the team. So we're continually invested in improving it. Some of the things we've been working on are, of course, always improving the error highlighting and making all these edge cases where red code that actually compiles doesn't get marked as bad. We've also worked on a few other things to make it easier to get started, like the one-click bundle. So my colleague Pavel once went through this and found you need about 100 clicks if you don't have, from a fresh system, to have a working IntelliJ IDEA with Scala plugin running. So what he did, he made this bundle, and you see, you just open it and you have a working Scala project that you can run and test and play with. Recent feature from last release is the, I don't know, I call it implicit radar or implicit X-ray. I don't know if you've seen it actually. So far we've only had tooltips, but now you just press a button and you get the implicit parameters that you're passing, or whether you're passing an implicit explicitly. Have you seen this feature yet? No? You just press Control Alt Shift plus and you will get these nice. Yeah, sorry, we ran out of free keys, you know. But yes, it's there. Look it up. It might make your life a little easier. If you're wondering why is this compiling or not compiling, what's this missing implicit, which implicit is actually used. Okay. Finally, the synthesis. Fork it harder, make it better, do it faster, makes us stronger. More than ever, hour after our work is never over. And my point being, yeah, we have lots of opportunities to make new tools, and we have all these old tools that we actually want to keep using a lot of the time. And creating new, maintaining old, it's not necessarily a dichotomy. We can integrate the old into the new. So agreeing on styles and tools as a programming community makes us more productive, cohesive. And so from the point of view of tooling developers, we've actually been coming closer together, especially over the past year, to work together on new things. So I've worked a lot with the SBT team. They've also cooperated with the Scala Center, and as well as me working with the Scala Center on new ways of integrating tools. John Purdy has also initiated the LSP, STP, so Scala tooling protocol working groups, so that we actually work together more, you know? Oh, one way of bringing things together, have you heard of the language server protocol? Just, yeah, many, not all of you. So actually it's a protocol developed for Visual Studio Code Editor by Microsoft, which allows you to get many IDE features into your editor. Now maybe I shouldn't be mentioning this because it's our competitor in a way, but the Metals language server is a language server based on Scala Meta, which tries to give you some of these features via LSP. And it's developed by Scala Center. Now likewise, in Scala 3, I think Martin mentioned it in his keynote on Thursday, it comes out of the box with a LSP language server to also give basic IDE features. Now, for the Scala plugin, this is not directly relevant because we, of course, have our own way of doing everything. But integrating build tools has been historically a challenge. Like, who's had problem with SPT and INTELLIJ? Just some of you, so maybe I'm not doing that bad of a job. But I've had lots of problems because there's always some edge cases to fix. And so if I wanted to support any more build tools, then this would just compound, and I could support maybe one more build tool with my time. So the alternative that we've been working on together with the Scala Center, again, is the build server protocol, which extends the language server protocol and gives a standard way for build tools to communicate the project structure to IDEs or language servers like Metals. This is a protocol that's supported by Bloop as a server currently. And there's already an implementation in the IntelliJ Scala plugin Nightlies. How much time do I have?
You have 10 minutes.
10 minutes. Yeah, then I'll show you a quick demonstration of how this looks. So this doesn't look very different from SPT. I open the akka project. I select BSP. Click Finish. And oh, I had it on the wrong window. That's unfortunate. But yeah, what you see here, I imported the akka project. It's not via SPT, but via BSP. But you see the whole project structure right here. I can click compile. I get a BSP build running, and a nice output of all the errors, which is nicer than what we have with SPT right now. And this is in part enabled by the protocol offering standard messages for compile errors and warnings and so on. So back to this. And well, lastly, I gotta mention various integrations that we already have or are working on. So yeah, we have already SPT, the Hocon configuration language, recently added support for AMMONITE scripting and Scala format. In the ultimate version, you'll have Play, Scala.js, akka, and we're currently working on supporting Spark. And the build server protocol is already in the Nightlies as well as in the upcoming release, but still as a hidden feature because it's kind of under development. Now I said I wanted to inspire you to do something yourself. Okay, maybe you aren't paid full-time to work on tooling like I am, but try to consider how much time you spend working around tooling, and if it might not be worth it for you or your organization to invest some time in this. And personally, I'm always happy to hear where your challenges with tooling are, so that we may support your use cases better. I can't promise I can do anything right away, but getting the feedback is very important. And as I said, like right at 3 p.m. after the fire alarm, I will be at the unconference just to hang out and listen to your troubles. And for as long as we got now, this is the question and answer pool. Just bear yourself, jump in, give me comments.
I didn't get a chance to say this about 5 minutes late incorrectly, so ask as many questions as you like.
If you don't have any, that's fine, or you can come to me personally if you think it's an embarrassing question.
Thanks so much, Justin.
Thank you. Thank you.
Actually ahead of schedule, so